Good morning, ladies and gentlemen. The COMPUTEX forum is about to begin. We would like to invite everyone to be seated. Please also put your mobile phone into the silent mode. Thank you for your cooperation. Good morning, ladies and gentlemen. The COMPUTEX forum is about to begin. We would like to invite everyone and also the media friends to be seated. Please also put your mobile phone into the silent mode. Thank you for your cooperation. Good morning, ladies and gentlemen. It's a great pleasure to welcome you back to the 2023 COMPUTEX Forum. COMPUTEX Forum, which has been held for the past 13 years, leading companies and industries leaders have generously shared their ideas, visions, and passions on this stage. Today's forum will focus on chips and semiconductor. There will be 8 outstanding speakers from the technology industry to deliver their speeches. Without further ado, please welcome Dr. Jack Sun, the Dean of Industry Academia Innovation School of the National Yangming Jiaotong University, to give us the opening remark. Ladies and gentlemen, let's welcome Dr. Sun.
Good morning. I really welcome you back to Taipei, this COMPUTEX after the pandemic. And you heard Monday, Jensen Huang's keynote. It's all the excitement. It's great timing, actually, after we have the pandemic. You know, the ChatGPT and all these 3D integrated computing technologies that enable the future computing. So today, I think we have 3 distinguished speakers later. We look forward to their talk. But since I'm the technologist besides the 3 experts on the system side, so I'll try to give you a little bit of how technology and chips design, the architecture and software, this positive flywheel effect. Actually, we are all about innovation, and we innovate together in the, it's since the invention of the transistor 76 years ago or 75 years ago. So, so if you hear what Jensen said, we are, into the iPhone age of AI. And the AI gold rush is here. And on the technology side, actually, people talk about whether Moore's law is over or whatever, but Moore's law is never single-dimensionally kind of thing. So right now, actually, everybody talk about chiplets, packagelets, and then 2.5D, 3D integrated. So I've been talking about 3D by 3D, this type of system integration and system super chips. Which actually, I was CTO of TSMC. We started the 3D type of work way back into 2006. And almost 10 years ago at the keynote, I talked about this. So chip technology, 3D, going, FinFET right now, nanosheet, all those future, just trying to get more sort of a functional scaling. Pack more functionality onto a single sort of area. And also we have this capability of integrating chiplets from different generation, different types. Then with all these wafer-based or other heterogeneous integration technologies. So what you see is actually if you take a human being, a biological world as an example, 3D CMOS is just like the brain. It's Moore's law continuing with whatever the innovation coming up. It's still ongoing. And people may not quite like the cost trend, but it's still improving. And we also have our senses and our arms and legs. That's all these sensors and specialty chips. And these put together, wired together, connected together with the 3D and 2.5D stacking. That's like the human spine. Just look at that analogy. There's no wonder right now we have all these super capable of computing that enable the AI and other things. So on the chip technology side, I think for those of you hearing all these buzzwords, you can still continue to see it's moving 3D. That's just logic and memory also. All your flash right now it's 3D. And this is I borrow from last year's TSMC's symposium, right? It's their N2 technology is coming up soon, and it's still continuing, although they did indicate, right, the nanosheet structure will be there. That's one example of how the innovation still continues on the chip technology side. And on the package side, integrated fan-out technology, and those started with like iPhone with DRAM package on the application processor, and also CoWoS. This is what NVIDIA has been using. They were, besides the FPGA, just chip partitioning. This is really give us the capability of near memory computing. Basically, you do have to move a lot of data between memory and the processor. In this case, the GPU compute chip. And by integrating with CoWoS, actually, you can get the bandwidth and also the per bit kind of power reduced, to enable all these better performance, power, speed, bandwidth, density, and the form factor, also time to market. Okay, so this is just what's going on. If you look at the past trend, basically nobody, the leader will not say and cannot let up on the chip scaling. So Moore's law will have to continue. They go hand in hand with this type of heterogeneous integration technology. And if you look at the NVIDIA A series before this Hopper, this Grace, it's already enabling the ChatGPT-4 kind of capability. And if you look at the total combined memory, transistor count, and the logic transistor count, everything, we are actually approaching the equivalent of the brain, which is 100 billion neurons, about 1 trillion transistors. So if you look at that, it's no wonder, I wouldn't totally say it's coincident, but there's a sort of a magnitude, the size, if you can have this type of memory and logic capability, equivalent to a human brain. Of course, we need all these computer architecture, these deep neural network, large language model, this kind of innovation together. Then, we're approaching the human capability, if you look at the ChatGPT. So, but the best is still yet to come. So, besides traditional computing, this von Neumann architecture, you have processor, memory, all separate, and then you just shuffle data in between, and so forth. That's kind of not energy efficient. So, no matter it's on the edge, portable thing, on a sensor, actually we do need to still take lesson from brain. Brain is memory and logic together. So compute in memory or in-memory computing does offer the promise of 100x improvement in the sort of operation per second per watt type of performance. So this is actually what my new school at NYCU is also. We have research projects working on this in-memory computing with new memory technologies combined with advanced logic as well. So what you are seeing here is from traditional processors, microprocessors, von Neumann, to NVIDIA type of near memory computing, and then to the future. That's still a lot of room to grow to enable the next leap from technology side and from the architecture side. So this is what we have been working on in terms of trying to do the compute in memory to enable better energy efficiency, more capable, you can call it sort of application-specific engines. So anyway, and what I want to emphasize here is this positive flywheel effect between technology and the chip design and software, the architecture. This actually is what the whole industry, ICT industry with semiconductor industry, with the software guys, all together, this positive flywheel effect. So people no longer talk about AI winter now, given the ChatGPT success and NVIDIA Jensen's talk, right? So anyway, we should co-innovate and co-optimize. And I use the term ACCoin. It's architecture. I should have added software, instead of Bitcoin. Okay, so basically, we have tremendous opportunity to innovate together to enable another big leap beyond what we call this generative AI big leap for our computing. So all the attributes can be, So I'll stop here, and we'll get our distinguished speakers to share their thoughts, and then we will have hopefully some fun in the panel discussion. Thank you very much.
Thank you, Dr. Sun. Please return back to your seats. Today, we are very honored to invite Mr. Mohammed Awad, SVP GM of Infrastructure Business of ARM. Mr. Awad will focus on freedom to innovate, the ARM Neoverse advantage. Ladies and gentlemen, please welcome Mr. Awad.
Tripped on that, getting ready to go do this earlier today too. So, thank you, Dr. Sun, for the introduction. Thank you all for being here. It's really great to be here in Taiwan, and they told me I had to start off with a video, so I'm going to start off with this.
The world runs on ARM, where a tiny thing means everything. From town square to Times Square, ARM is defining the future of computing. A future built by one of the most successful technology ecosystems in the world. We fueled the smartphone revolution and will power every technology revolution moving forward. We are defining the next universal mobile experience and redefining what's possible in IoT and automotive, in cloud computing and the metaverse. A 30-year history of trust and security and a legacy of energy and power efficiency brings hope for a sustainable future. We changed the world once. Now we have the chance to change it again. The future is built on ARM.
So now I remember why they had me start with a video, because it gets me excited. I really love that video, and I gotta say, thank you all for being here. It is fantastic to be back in Taiwan. I haven't been to Taiwan since before the pandemic. It was 2019. A lot has changed in the last 4 years. A lot has changed in the last 4 years. What I love about that video is it highlights, how ARM has really been pervasive and kind of all over our world every day. Many of you know ARM. I'm going to tell you a little bit more about it today, and I'm looking forward to that. Analysts say 70% of the world's population use ARM every single day. In fact, looking into the audience, I see some of you using it right now. You're on your mobile phones. But that's okay. Keep going. It's good for business, so just keep that up. In all seriousness, what ARM does is we deliver this leading IP across all sorts of compute platforms. Over our 30-year history, we've delivered over 250 billion chips alongside our partners. It's staggering. In the first 10 years, the partnership delivered about 1 billion chips. In the last 4 years, since 2019, collectively, we've delivered 100 billion chips. That just gives you a sense for how quickly things are scaling, how fast this is accelerating. And we're incredibly proud of it. Since 2019, the pandemic and digital transformation has really changed everything. They've brought chips and AI to the center of the conversation. Chips are cool. They weren't cool in 2019. But I figured out they were cool during the pandemic when my 12-year-old son, over dinner, started explaining to me supply chain logistics. He wanted a GPU for his new gaming PC, and he couldn't get one. I thought that was the moment when I realized, when my 12-year-old was talking about it, that this was really starting to become something that everybody was paying attention. And of course, now, over dinner, he talks about how his friends are cheating on their homework with ChatGPT. The point is, semiconductors are, an incredible part of our everyday lives. In fact, earlier this week, we launched our TCS-23. TCS-23 is the platform for mobile computing. It's built around our fastest CPU ever, the Cortex X4, and our 5th generation GPU, Immortalis G720. This platform is all about enabling developers and the entire ecosystem to build the best visual experiences on ARM. And we've already partnered with folks like MediaTek and TSMC and ASUS to bring those experiences to life. Together, we're going to enable a platform that developers are going to be able to really move the bar on what it means to be a mobile experience. I encourage you guys to check it out. But ARM's about a lot more than mobile. One of the areas where we've had a tremendous amount of traction is automotive. We've been shipping into automotive for over 25 years alongside our partners. And that's a big deal in an industry where supply chain security and stability are so important. Many of you may not know that 85% of IVI and cockpit systems are actually based on ARM. 50% of ADAS chips are based on ARM. A big reason for our success here is because we took a look at the market and we deliver IP which is custom tailored to that market. We add things like functional safety to our processors, our GPUs, and our ISPs. But more important than that, we're actually driving automotive software ecosystem in an entirely new direction with initiatives like SOFI. Beyond that, we've had tremendous success in IoT. In fact, our market share in IoT is approaching 70%. It's fair to say that the IoT already runs on ARM. IoT is this really interesting place within the ecosystem. It sits at the intersection of AI and those endpoints, IoT. Right at that intersection, you see computer vision. Computer vision is really taking off in a big way, and I want to highlight one particular partner that we have that's based here in Taiwan, and that's Himax. Himax has long been known as a company which built these modules for laptops and PCs that could do identification. So you open your laptop, it knows who you are, and it allows you into the PC. But they wanted to do more. They wanted to leverage that experience they had to really create a platform so they could support all sorts of different use cases. And so we actually partnered with them using our ML IP, the Ethos family, using our MCUs, and leveraging our software ecosystem. They were able to launch a product back at Embedded World and turn themselves into a platform company so now others can develop and innovate on top of them. It's a great example of how they've transformed their business by leveraging ARM's technology. In all three cases, there's this kind of common theme. Whether you're talking about TCS-23 and the best visual experiences running on ARM, whether you're talking about automotive, or whether you're talking about IoT. In all three cases, ARM is doing the same thing. We are accelerating time to market for our partners, we're helping them reduce their investment, and we are enabling innovation. And that applies to infrastructure as well. You see, infrastructure is under tremendous pressure. In 2019, there were 0 5G subscribers. Today, there's over 1.5 billion. 1.5 billion, each of which has 10 times the bandwidth available to them. In 2019, there were about 5 billion IoT connections. Today, there's about 10 million more. The result of all that is about 4 times the data that is being generated every year. That's a tremendous amount of data, 120 zettabytes. And I'll save you all the Google search. A zettabyte is 1 billion terabytes. Just think about that. And on the other side, we have science and politics. Dr. Sun talked about Moore's law. It might not be dying, maybe it's slowing. The point is, it's not what it used to be. It's creating tensions, this idea of continuing to just rely on the process nodes to give us 2x. It's not living up to that. And then you've got sustainability. You know, in some places, they're actually limiting housing development. Specifically in London, some boroughs are limiting housing development because of the power being used by the local data center. They can't support any more housing. Worldwide energy consumption for data centers between 1% and 3%, depending on the analyst you look at. And in places like Ireland and Denmark, it's even higher, 14%, 7%. Those are big numbers that we're talking about. And then we've got this thing that's happened, which is this sort of shift to specialized processing, which is really a response to it. You see, CPUs of 2019, they were Swiss Army knives. State of the art was a 28-core device. That was it. You used it for everything. In the last 4 years, the ecosystem has flipped that on its head. In 2023, CPUs are specialized. You have cloud-native processors with over 100 cores. You have high memory bandwidth systems, which enable a lot more bandwidth on the device, whether that's to memory or to peripherals. You have edge devices, which have been optimized for power and have acceleration built in. So there's all this innovation that has happened over the last 4 years specifically to address that problem. But you know what? That innovation isn't free. It comes at a cost. And I think Dr. Sun, mentioned that as well. According to IBS, a 2-nanometer chip development on an advanced process node could cost as much as $700 million. $700 million. That includes all of the software, the IP, the verification. And it turns out, if you dig a little bit deeper, that those 3 things are actually the biggest chunk of the cost. Software, IP, and verification. That's where ARM comes in. You see, ARM Neoverse is the foundation for the future of computing in the infrastructure. It's the foundation for the future of the computing in the infrastructure because it's solving that problem. 3 simple reasons. First, technology leadership. Second, enabling the ecosystem the freedom to innovate. And third, and arguably most important, a unique dedication to a collaborative partnership with our ecosystem that has been ARM's superpower since day one and continues to be so moving forward. Let's get into each of these in a little more detail and start with technology leadership. Back in 2018 and 2019, we launched our ARM Neoverse brand. Since then, we've had 6 new cores that we've announced. We're really broken up into 2 main product lines, our V-Series and our N-Series. Our V-Series cores are really all targeted to performance per thread. These are about scale up. They're really good for things like HPC and AI. They provide about 15% better performance than the latest generation from x86 on a per thread basis. And then we have our N-Series, which is really focused on scale out. These are great for things like web servers and networking. They sort of lead in performance per watt. Our partners, our cloud partners specifically, love the N-Series cores because they provide 45% better perf per watt over offerings from x86. This is why you're seeing such adoption in the market from a lot of these partners. The point that I'm trying to make is that the ecosystem, the infrastructure, is spread out into these 2 different types of devices. And what we've done is we've created CPUs which enable the ecosystem to go innovate and service both parts of the market. But everybody knows about our CPUs. That's a common thing that people think about and associate with ARM. What people might not realize is that we have technology leadership in a lot of other areas. And system IP is another fantastic example. Our CMN interconnect is second to none. It's unmatched in the industry. It's the key to scalable efficiency, letting partners scale from a very low core count to a very high core count, up to 256 cores. And it does so at an incredible cross-sectional bandwidth of nearly 4 terabytes per second. On top of that, CMN supports all the major peripheral and chip-to-chip standards. That includes things like AMBA-CHI, DDR5, UCIe, PCIe, CXL. But we're taking it a step further. We're showing technology leadership in systems as well, because we don't just provide IP. You see, partners more and more are looking to find ways to bring that big number down that it costs to build silicon. They want to innovate around compute subsystems, and so more and more, that's what we're delivering. We've brought together CPUs and interconnect and key system IP, and we integrate it, we configure it, and we validate it. And then we hand it to partners so they can take it right to physical design. This is all about saving partners time and valuable resources. And I got to tell you, it has been incredibly successful. We actually have partners we have multiple partners who have taken this already, and some even have silicon back. One customer had silicon back 13 months from project kickoff, with 100 cores booting Linux. 13 months. That 13 months, it includes cycle time in the fab. Another partner told us that it saved them 80 man-years worth of effort. Partners are leveraging the investment that we've made so they have a platform to innovate around. The focus of their investment is innovation. That's how we solve the challenges and the pressure on infrastructure. Let's talk about innovation, because boy, are we seeing some of that innovation in action. You know, not having been here for 4 years, I've been talking to people all week. And one thing that has surprised people is how much innovation has happened on ARM in the last few years. If you look at all of the major firsts in the industry around infrastructure, they've actually happened on ARM. The first silicon to 1 terabyte per second memory bandwidth. The first to 100 cores. The first to DDR5 and PCIe Gen 5. The first to LPDDR5. The first DPUs, all on ARM. DPUs specifically are a huge deal. If you're not familiar with what's happening in the DPU market, it's fundamentally re-architecting the infrastructure. Okay? It's re-architecting the data center. It's all about disaggregation. We're disaggregating the compute functionality that's used to manage the infrastructure from the compute functionality that's required to run the application. This is driving a tremendous amount of efficiency within the infrastructure. You know, Facebook is famously quoted as saying as little as 18% of CPU cycles are spent on core applications, and the rest are just managing the infrastructure. This is about specifically going after that. And if you look at it, we've seen tremendous innovation from our entire ecosystem, whether that's AWS Nitro, NVIDIA Mellanox Bluefield, Marvell Octeon, Intel Mount Evans, AMD Pensando. DPUs are being built on ARM. Another great example, and I won't dwell on this one too much because my buddy Jeff is in the audience and he's up next, is the work that's happened with Ampere. Ampere's done a tremendous job sort of paving the way for this idea of having a whole lot of cores per SoC. Their latest product, 192 cores. They now have a complete product family from 32 to 192 cores. And they're doing so in a tiny, tiny power budget. Again, I'm not going to get into too much detail because I want to let Jeff talk about it, and I'm sure he's going to. But this is some incredible innovation. And what we're seeing from the competition is they're really following us into that area, which is fantastic. It's showing real leadership. And then there's this one. Some of you guys might have heard of this one this week, right? NVIDIA Grace. I had to bring up AI because you guys were starting to fall asleep. It's about halfway through the discussion, and I figured that would get everyone awake again. This one is showing off tremendous innovation as well. This family of products was really built and designed specifically to achieve unparalleled performance per watt. You know, we're seeing that in HPC and AI workloads specifically. It's either leveraging one, in the case of Grace Hopper, or two, Neoverse compute subsystems based on our standard, off-the-shelf Neoverse V2 core. This is incredible. It's got incredible memory capacity. It's got unmatched CPU to GPU bandwidth. And you know, you heard Jensen say, he held it up, right? And what did he say? This is a computer. It's not a chip. Well, if that's a computer, then the CPU at its heart is ARM Neoverse. It's fantastic to see this sort of innovation that we're enabling. And I love this particular use case, which he talked about as well, which was really about the partnership that we have with SoftBank and NVIDIA to really reinvent what a 5G data center is. You know, SoftBank's building the world's first AI data center with Grace Hopper. They're talking about 4 times the ROI. But why this thing is so special is because it's solving problems in 2 different parts of the market, which people have been talking about. For those of you that aren't familiar, there's been this challenge with Open RAN over the years, right? Are the economics going to work out? The telcos saw the benefits, but are the economics going to work out? So there's been that. And then there's been this other issue with the IoT and 5G in general, where there was this promise of being able to support all of these edge devices and to be able to do all of this compute on the edge to support all this data coming from the IoT devices. This announcement solves both of those problems. Because you can leverage and create multi-tenant environment, you can get 5G Open RAN for a much better ROI, because you can leverage that same hardware to do AI on the edge. And because you can do AI at the edge, right where that 5G happens, all of a sudden all those devices sending data in can actually do something useful with the data, which has been what's holding IoT back. That's innovation. And none of this would have been possible without our partnership. Our partnership with NVIDIA, our partnership with SoftBank. You see, it takes an entire ecosystem to deliver this type of innovation. That's ARM's superpower. And it's why we work with all aspects of the stack, whether that's the silicon, whether that's the foundries, whether that's the ODMs. We engage at all different levels to make it happen. And we, of course, a big area of investment for us, a big area that we spend a tremendous amount of time is the software ecosystem. In fact, it's one thing that I get asked a lot. How is the software ecosystem doing for ARM? What about the software ecosystem? That box looks kind of skinny at the top. So I figured we'd do a slide on it. This is just a small set of the software that's now supported by ARM. This represents over 15 years worth of investment. The result of all that investment, all the major languages, all the major libraries, all the major tools, all the major OSs now support ARM as a first-class citizen. So there are 15 million developers that develop on ARM, for ARM. Millions and millions of developer hours, specifically on ARM v9. And this is growing rapidly. For example, in 2019, last time I was in Taiwan, we announced that NVIDIA's CUDA would support ARM, and the approximately 600 AI and HPC applications that were supported on CUDA. This was in 2019. Today, that number is 3,000. That's the rate at which it's accelerating. That's a 5x increase. But it's not just increasing because of the investment that we're making, or partners like NVIDIA are making. It's increasing rapidly because of the massive adoption that we're seeing with ARM across the board. Every major hyperscaler has now adopted ARM-based instances, and we're incredibly proud of that. Not only are they providing public instances based on ARM CPUs, but they're also adopting ARM-based DPUs to re-architect their infrastructure. And for them and their customers, it means a massive increase in cost savings. In fact, AWS has been quoted as saying that 48 of their top 50 customers are using their AWS ARM-based Graviton chips. The result of all that is an acceleration in the investment in the ARM ecosystem. That's our partnership with the ecosystem in action, and we're incredibly proud of it. You see, the future of the computing infrastructure is being built on ARM. And that's thanks to the technology, the leadership, and the innovation that we are enabling. But most importantly, it's because of our partnership with all of you, the broad ecosystem that makes up ARM. You see, ARM technology powered the smartphone revolution. That's a revolution that has undeniably changed all of our lives. We now have the opportunity to do so again. Together in partnership, we can transform infrastructure so that it's more performant, so that it's more efficient, so it's more sustainable. And we can do so while delivering on all those advances, all those promises that are being made by things like the age of AI and beyond. I'm looking forward to doing it together with all of you on ARM. Thank you.
Thank you, Mr. Awal, for your inspiring speech. Please return back to your seat. Sustainability has become a crucial issue to the technology industry. The next speaker may have a solution for all of us regarding to this topic. Today, we are very honored to invite Mr. Jeff Wick, Chief Product Officer at Ampere Computing, to talk about cloud-native processors, sustainable compute solutions from edge to cloud. Ladies and gentlemen, please welcome Mr. Wick.
All right, thanks everybody for being here. You know, it's been great spending this week in Taiwan with so many great partners and with so many amazing innovations occurring across this industry today. I'm going to talk a little bit about the key challenges that are facing our industry and the new approach that Ampere is taking to address those challenges. Ampere was founded about 5 years ago to be a modern semiconductor company, one that was going to shed the baggage of legacy CPUs and reinvent what compute means, specifically in the cloud. And we set out to solve some of the key challenges to deliver a more sustainable cloud. Because, you know, for as great as all the innovations in the cloud have been, we're able to stream our favorite TV shows, we're getting amazing breakthrough innovation via Gen AI. The problem, though, is amazing as those things have been, and as many innovations that have come out of the cloud, the thing that the cloud has not delivered yet is sustainability. Today, the cloud is not able to continue to grow at the pace that it has over the last decade without major changes being made. Today, the cloud and data centers in general already consume as much as 2, 3, almost 4% of all power in the world. And that's just today. Unabated demand could cause us to climb rapidly over the next few years. You heard about some of the challenges. The housing challenges in West London. You know, specifically there, applications for new housing developments in West London have been put off until 2035, over a decade from now. There's other areas in the world that are facing those same challenges. Northern Virginia, where a lot of the data centers in the United States East Coast are located. Because of the lack of available power, data center operators are actually starting to use their backup generators, not just for backup power, they're using those generators for sustained periods throughout the day in order to just power the daily operations of their data center. So the list goes on and on and on. And these data centers are being built in the same regions because of where network connectivity comes through globally, whether that's Ireland, whether that's London, Singapore, Amsterdam, the Bay Area, many of the places in the world that have the largest constraints on power and have the largest real estate constraints. On top of that, even if sustainability isn't your top concern, power costs have increased tremendously, especially in Europe over the last several years. So at the end of the day, the cloud's future compute capacity is completely reliant on the available power. And since servers are directly responsible for the majority of that power, we have a great opportunity to solve this problem here as an industry. And it's a great time to do so. We're about a decade into the shift from previous eras of compute, from the client-server era that was dominated by x86 CPUs, into the cloud era. And what typically occurs in these types of transitions from era to era is the usage model changes. And that's followed by a massive shift in the software that's running on that infrastructure. We're well underway in that in the cloud. The usage model changed to a distributed cloud model delivering vast amounts of compute around the world. The software model has changed. Software has moved to more distributed, containerized applications running across large numbers of nodes, large numbers of servers, large numbers of CPUs. What hasn't changed, though, is the underlying hardware. That's the third piece that needs to change. And that typically does occur about a decade in. The usage model changes, the software model changes, and then the underlying hardware changes. And that's what we have been hard at work developing at Ampere, is a cloud-native processor to match that cloud infrastructure and the cloud-native applications. And as I mentioned before, power is the main limitation to continuing to expand. So if the total amount of power that is available for the cloud is the limiter, then the goal is to deliver the most compute in a given power envelope. The most compute per data center, the most compute per rack. And there's multiple ways to deliver more compute. We can move to a scale-out approach, or we continue to scale up. And a scale-up approach suited us very well over the last couple of decades. Maximizing the performance per core, was able to take advantage of increasing transistor performance at the process node side. As long as Dennard scaling held, single core performance was able to double around every 18 months, no increase in power, and the cost was able to reduce. However, once Dennard scaling ended around 2005, we saw multi-core x86 CPUs. And that was challenging on the client side because that requires code parallelism in order to take advantage of all of those cores. That's not the case in the cloud. In the cloud, where applications are already spread across many, many nodes, across many, many servers, many, many cores, we have a great opportunity to use a scale-out approach in order to deliver increasing amounts of compute performance without increasing the power consumption. So in order to reverse this trend of increasing performance costing increasing power, Ampere has sought to bend that curve, really introduce a completely new curve. So instead of a world where increasing the amount of performance means just throwing more power at the problem, we're operating a different regime, where more and more performance can be achieved without increasing power. Because at the end of the day, it's not a trade-off between performance and efficiency. Again, if the cloud is ultimately hemmed in by the amount of overall power, increasing performance means increasing efficiency. Performance and efficiency go hand in hand. And what have we done? We've shed a lot of the baggage of legacy x86 CPUs. A lot of features that were useful in client environments are just no longer useful in the cloud or wasteful and consume too much power. We sought to deliver exceptionally consistent performance, which allows our users to increase their utilization, another way to improve efficiency. We ensure that our cores scale incredibly linearly. Adding more cores means getting the proportional amount of performance. That's what's expected in the cloud. And we're delivering general purpose cores that can be used very flexibly across any application that's running in the cloud. That's what we've done with our first generation, our first family of processors, our Ampere Ultra family. Back in 2020, we introduced the 80-core Ampere Ultra processor. We increased that to 128 cores in 2021, the first processor in the industry to pass the 100-core mark. And these really set a new bar for the data center with that predictable high performance that's based on a cloud-optimized architecture, single-threaded cores to deliver the consistency and the isolation that users are looking for, extreme scalability across the cores, and a completely new level of power efficiency. We consume roughly 1 watt per core. And we call this a cloud-native processor because we built it from the ground up for the cloud. Just like cloud-native applications are well-suited for a cloud infrastructure, cloud-native processors are well-suited for a cloud environment. And we talk a lot about the cloud, but our processors scale incredibly well across virtually any compute environment. So whether you're deploying in large hyperscale data centers and you're looking to deploy the maximum number of cores per rack, or if at the other end, you're deploying out in a very distributed edge location where power is a real premium. You're not deploying racks of processors, you're maybe deploying a couple of processors out at the edge. Power, space, thermal, these are all key constraints. And so we could deliver, say, a 32-core processor at 40 watts. So regardless of where you're deploying, Ampere is able to scale to meet your needs. And I want to show you a couple of the platforms that we have out there right now. We've had some great partnerships with OEMs and ODMs around the world. I wanted to highlight first the RL300 from HPE. I won't lift it up, but I'll tip it forward a little bit. So this is the HPE ProLiant RL300. It's a 1U rack mount server. It delivers up to 128 cores. And this has been a real breakthrough in terms of the adoption of Ampere processors around the world. You saw that there are hyperscalers around the world that are deploying our Ampere Ultra processors, and the HPE ProLiant platform has really helped us grow into the on-prem private enterprise space as well. This is a great platform. Not only is HPE supporting this with their standard ILO management software, but also they're supporting OpenBMC. So it's been a really great partnership with them, not only bringing a new type of technology forward, but really embracing the open source community as well. I have another form factor here. So this is the ASRock Rack Micro ATX board. This just came out in the last couple of weeks. This is a really cool form factor platform. So nice and small, dense. This is great for edge deployments. Again, 128 cores. You could deliver that in 125 watts. 8 channels of DDR4 memory. So a lot of performance in this. You know, to put it in comparison, at the edge, Ampere processors are delivering 4 to 5 times more performance in these power envelopes as existing x86 processors. Solving a really key problem, because while years ago the edge was maybe dominated by lower performance processors consuming a small amount of power, today with the rise of AI, additional analytics workloads, the performance requirements in the cloud are really the same as the performance requirements, or at the edge are the same as the performance requirements in the cloud. It's the same type of workloads. You just have a very, very constrained environment. So we're really, for the first time, able to bring cloud-level performance out to the edge in these types of platforms. And then the third one here is from 7 Star Lake. This is a really cool, rugged edge platform. This one is very rugged. I'm not going to try and lift this one up too far, but this is a really, really cool, innovative platform. And I'd like to bring our partner from 7 Star Lake, Martin Ting, the CEO of 7 Star Lake. I'd like to bring him up here to talk a little bit about it.
Hi, Jeff. Good morning.
Hey, good morning, Martin.
Yes.
All right, so I wanted to ask you first, how did you start the partnership with Ampere? How did this come about?
Okay, as you mentioned about, actually, most of the people are actually currently in the age are looking for multi-com the processors. And actually, the Ampere processor, we learned the name. It's from kind of autonomous driving industry. As you might know, Star Lake is working in the L3 to level 5 autonomous driving for a long time. And then at that time, many of the research institute introduced me, hey, Martin, there's a company called Ampere. They have the 32-core processor, but only less than 40 watts. Would you like to using that processor to make a GPU server for our level 5 autonomous driving car for F1? So that's how I learned your company. And then we started collaborations.
That's great. And it's a super impressive system. So why then did the Ampere technology, how did that benefit 7-Star Lake? How are you using this?
Yeah, okay. As the audience can see, you know, using this rugged design based on the Ampere, the 32-core, or even actually we just tested 64-core, fanless, and it's ultra low power. As you know, with the increasing computing power needs, when we need to connect with multiple sensors, such as 3D LiDARs and the multiple cameras. So every of the transportation platform, we are kind of about the computing hungry power, the hungry. So we need about this kind of Ampere processor can help the system integrator like a 7-Star Lake design the nice and small footprint, small form factor, rugged computer for all of the transportation customers.
That's great. So you're able to deliver the high performance that your customers want in these environments, but really just SIP power. You don't even need an active cooling system in it. So it sounds like that really opens up a lot of use cases. Can you tell me a little bit about some of the use cases for this platform?
Yeah, we are working with the Ampere closely, and now we are going to launch about 3 products based on the 32-core, 64-core, and even we get up to 80 cores. And actually, it's already have the global leading customers from the European leading rolling stock company, the Bombardier, Hitachi. As you know, currently the computer vision is very important for public security. So the customer like Bombardier is willing to using the Ampere 32-core and to link with 16 cameras and with fanless and no latencies. It's great. And the second one, as you know, the defense industry is getting more and more important. So actually the Ampere product is not only can using in the commercial market. Actually in defense market, we see more and more our customers, okay, like Lockheed Martin, Raytheon, they want to using the list AA320 with NVIDIA MXM GPU and do kind of about the sensor fusion in aircraft or in different kind of armed vehicle. And the last one is also most important one. The autonomous driving is still very important. It's kind of about block technology. So actually, the most of level 5 of the players, they want to using the 64-core, the Ampere processor, with low power and integrate with NVIDIA most power GPU. So actually, these 3 products is widely using in those the vertical sectors, and we will believe these 3 vertical market will have enjoy the benefit from the Ampere low power, high core counts. Thank you.
All right. Well, perfect. Thanks, Martin. This was awesome. Really cool to see your innovative platform, and appreciate the partnership with 7-Star Lake.
Yeah.
Okay, so as you've seen, Ampere processors scale from cloud to the edge. We have a variety of different platforms. This is just a sampling. There's actually over 50 different platforms that are available for the Ampere Ultra family processors. You'll see some of them around here over the next couple of days. So what runs on Ampere processors? Anything running in the cloud runs on Ampere. But specifically, when we look at it, the applications that really excel, we're talking about cloud-native applications, everything from web servers, databases, in-memory caching, media servers, AI inferencing, cloud gaming. So virtually everything that runs in the cloud runs well and runs best on Ampere. So you saw it spans from cloud to edge. Now, what's the benefit to those who are running in these environments? It's about a couple of things. One, it's about performance per rack. When we're talking about the cloud, we're talking about hyperscale. As I mentioned before, the cloud has a set amount of power. Hopefully that power actually decreases over time. And so if the cloud has a certain amount of power, you can break that down into the amount of power available per data center. And then every rack has a specific power limit within the data center. So if you can maximize the performance per rack, you've maximized the performance at the cloud level. Now that's not what everybody cares about. Out at the edge, it might be about performance per device in a specific power and space envelope. If you're a user of the cloud, maybe it's about performance per dollar or performance per cloud spend. And you might care also about the carbon emissions and the sustainability aspect of those cloud providers. It's a wide range of solutions available. I'm going to walk you through an example here. So let's use an example of a real-life web service at scale to show you how Ampere delivers so much value. So we'll use a fairly high-trafficked application or website, say something that needs to service about 1.3 million web requests per second. Okay, sounds like a lot, but that's a pretty common use case. So modest web workload. There's a service level constraint to it. You need to deliver each web request in a certain number of milliseconds. And then the goal is to scale out and be able to manage all of those requests in the smallest possible footprint. Okay, and so when we look at this, the question we ask is, how many racks are required to service this workload? And when we look at this, we really call this the performance per rack barrier problem. Okay, so you want to figure out how much performance can you deliver per rack for this workload. Now, if you were to do this with Intel Xeon CPUs, you'd fill up one rack. You still haven't hit 1.3 million requests, so you'd fill up a second rack of servers. Man, you still haven't hit 1.3 million requests. You have to actually move to a third rack before you've been able to service all these web requests. 3 racks with Intel. AMD, similar case. First rack isn't enough, so you need a second rack before you can service 1.3 million web requests per second. We can do this on our Ampere Ultra processors with just one rack, 36 CPUs. That means a third the power of Intel and a third the rack space as Intel. So much, much more efficient solution. And so this performance per rack metric really encapsulates all the things that matter. It's performance, it's power efficiency, it's space. Let's go a little bit under the hood. What was that made up of? The web service is made up of a number of different applications, Nginx, Redis, Memcached, MySQL in this case. And so this starts to show you how we're able to deliver such amazing performance at scale. It's about delivering multiple times more performance per watt in very high core count processors. That gives you the density that you need for cloud workloads. We can look at each individual metric. So Nginx, that's the most popular web server in the world. Over 30% of all websites are powered by Nginx. Now, compared to Intel, we're delivering 4 times more performance per watt, almost 3 times more performance per watt versus AMD. Go to Redis, similar story. Over 4 times more performance per watt than Intel, and you can see how this translates into almost 3 times more performance per rack for Redis. Memcached, same thing. Incredible amount of performance per watt, and performance per rack. MySQL, a good example on the database side. You could pick a number of other databases, Cassandra, MongoDB. They would show similar results. So exceptionally better performance and better efficiency. And the net result of this is not just great performance, cost savings, it's also about sustainability. So if you were to take one medium-sized data center, convert it over from Intel-based processors over to Ampere processors, you could save 201,000 metric tons of carbon a year. That's the same amount of carbon emissions that 245,000 acres of forest capture in carbon every year. It's the equivalent of taking 40,000 gas-powered cars off the road. This is making a big difference globally, not just for data center operators, but for everybody. So at Ampere, we also have a very robust roadmap of additional processors. There's the Ampere Ultra family. We continue to innovate with Ampere 1. Ampere 1 is our latest processor. This takes us up to 192 cores. I have one of them right here. So this is the Ampere 1 processor. This is our latest family. It's shipping right now. It's in production. And this is really the path to breakthrough performance. What does Ampere 1 do? Ampere 1 delivers more performance, more scalability, more I/O, more memory bandwidth. It extends that performance per rack lead, 192 cores, an exceptional amount of compute density. DDR5, PCI Gen 5 for additional memory and I/O bandwidth. And because it was designed for the cloud, it also contains additional cloud features that are exceptionally important for our customers and for our users. So as I mentioned, Ampere 1 extends out that portfolio of products. We now have a full breadth of products from 32 cores to 192 cores. Ampere 1 takes advantage of some of the same architectural tenets that we believed in from the start, things like single-threaded cores, delivering very consistent frequencies. These are really important in the cloud where every user expects a predictable amount of performance at all times. We have very large private caches. The L2 cache on this product is doubled from 1 meg per core to 2 megs per core. Right? And with 192 cores, that's a ton of L2 cache. Why does this matter? We really want to focus on delivering the maximum amount of private cache to our cloud users so they can avoid resource contention, noisy neighbor problems, keep as much of their working data in the private cache as possible. This product was also developed with AI in mind. We acquired a company about 2 years ago, OnSpecta. And OnSpecta has been delivering amazing software libraries that are now integrated into PyTorch and TensorFlow, and this is one of the reasons why we've been delivering exceptional AI performance on our Ampere Ultra family over the last couple of years. Well, that same team that was developing these software libraries was also hard at work on hardware optimizations, hardware architectural features for our future processors, including Ampere 1, to deliver more and more AI inferencing performance. So we added to the existing set of features of the Ampere Ultra processor, we added, in addition to FP16, int8, int16 support, we added bfloat16 as well. And that really shows in the amazing performance results that we're seeing. I mentioned features. We delivered features in a couple of different categories. We delivered features in performance consistency, scalable manageability, and security. I'm not going to go into detail on all of these, but in the performance consistency front, we were facing some new challenges that we hit for the first time in this industry, 192 cores. That's over twice, that is twice the amount of cores that any of the other products in market have today. So we had to develop new features that help to manage traffic, manage congestion around the mesh. This product is also our first chiplet-based product. And one of the key distinctions in this chiplet topology is that all of the cores are on a single compute chiplet. That's really important in the cloud where you want to minimize the number of hops as you move around the SoC, minimize the performance inconsistency. To do that, we needed new performance consistency tools, things like the mesh congestion management feature that I mentioned, being able to manage memory and SLC consumption and bandwidth across users in a multi-tenant environment. On the scalable management front, being able to provide more granular power controls to the infrastructure operator in order to be able to monitor power consumption and optimize it over time. Internal features like our advanced droop detection that allows us to run at the lowest possible voltage at all times and save power. And on the security front, a number of really innovative features. One, single key memory encryption that allows additional security for those who maybe don't have physical control over all of their assets. Maybe you're a CDN, you've got servers sitting out in POPs around the world. You may not always have physical control of those servers. Single key memory encryption ensures that even if a bad actor does gain physical control, they're not going to actually be able to read the contents of memory. And lastly, probably my favorite feature in here is memory tagging. Memory tagging is one that I could personally say customers have asked for over a decade. And this feature doesn't exist anywhere in the x86 roadmap. Memory tagging accomplishes a couple of things. This provides additional security, ensuring that even if somebody were to execute something like a buffer overflow attack, that users aren't going to get access to memory space they shouldn't have access to. It also helps on the data integrity side with large applications like databases. So we have a couple of customers that are very excited about that and are using this feature today. We have a very, very large ecosystem of partners, so it's very easy to get started. I want to focus on really what to do today to get started. There's a couple of stages. First, learn more. You can go to our website, learn about our performance per rack metrics, learn about how you can take advantage of the density of our cloud-native processors. And then assess and plan. We have Ampere-ready software references, blueprints, guides for you to get started on some of those applications that I showed before, NGINX, Redis, Memcached, AI inferencing with TensorFlow and PyTorch. And then start building. So use our workload and solution briefs that are also available on our website, and then start to test and optimize. We have porting guides available in our Ampere developer community. You can interact with other users, share your success stories, and then deploy. We have Ampere instances available at leading hyperscalers around the world, from Oracle Cloud, Microsoft Azure, Google Cloud, all the leading Chinese hyperscalers, as well as local providers, especially across Europe. Main.pl just announced this week that they have brought services available with Ampere processors. So in Europe, Main.pl, Scaleway, Hetzner, Glesis, G-Core out of Luxembourg, for instance. So providers all across the world have Ampere Ultra processors available, and they'll be bringing Ampere 1 processors to the market. And as you saw here, there's many platforms available as well to get started on. So at the end of the day, no one can ignore the need for efficient compute at scale. And we're really leading the way. So if you build your own cloud, you can run at high performance, high utilization. You won't need to build new data centers. You won't need to procure more power. You don't need to overhaul your infrastructure. If you run in the cloud, you're going to have an exceptional experience right out of the box. You can scale to higher performance, scale to more cores, while using less resources, both power and money. And if you're developing cloud-native applications, you're really going to love the fact that our cloud-native processors, they run and they scale the way that your applications do. And if you're just a beneficiary of all the goodness of the cloud, you're running apps on your phone, you're watching streaming videos, exploring AI breakthroughs like GPT, you can feel good about the fact that with Ampere cloud-native processors, the cloud you use is sustainable. The choice is clear. Innovate today with sustainable cloud-native processors from Ampere, better performance, lower power, a more sustainable cloud. Thank you.
Thank you, Mr. Rick, for the inspiring speech. Please return back to your seats. Today, we are very honored to invite Mr. Andrew Huang, Senior Professional of High-End Systems at Lenovo, to talk about empowering transformation from edge to data center to cloud. Ladies and gentlemen, let's welcome Mr. Huang.
早安，刚刚都是讲英文哦，但是我也要讲英文。So I just say good morning to everyone because I just say everyone you guys from US or other country. I'm in Taiwan, but I need to speak English. So good morning, everyone. My name is Andrew Huang. I'm actually working in Lenovo. So I look at the subject, the semiconductor. Actually, Lenovo is nothing to do with the semiconductor. And 2 hours ago, I met with Mohammed. I talked to him, hey, I have nothing to do with ARM. He asked me why. I say, after 5 years, I'm going to retire. But after I'm sitting here, listen the two presentations, I think I need to change my mind. And I think today will be changing my life because ARM is important. And I'm going to embrace ARM. Thank you. So today, I'm going to talk. Next one. Today I'm going to brief, because I'm not talking about a semiconductor, so I'm going to take you through some x86 industry and how Lenovo designed a server. So this is the, I hope I can bring you lots of information in the server industry. So if I have time, I can talking about cycling. If you would like to hear my cycling history, I can tell you today. And before I start, I want to introduce Lenovo. Actually, Lenovo is a company. We have 3 groups. I'm from ISG, the Infrastructure Solution Group. And we also have IDG, and we have a SSG to bring the solution to customer. And if you look at the screen and here, we provide not just the PC notebook, which is purchased from IBM. We also have the mobile phone. You see the mobile phone That is a folding mobile phone from Motorola because Lenovo purchased Motorola in 2014. And I'm from IC, so we provide a system to our customers. And also, we have the storage can provide our customer. Lenovo just announced the finance report 2 weeks ago. You see, last year we did 62 billion. And in the screen, you can see the ISC I am working on. Last year is our historical high revenue, which is almost 10 billion, which is 9.8 billion. And in the screen, you also can see Lenovo is very committed to our customer for the R&D. So last year, we spent 2.2 billion to the R&D. And I'm working with the server group, so I want to introduce the server market to you. So if you look at it here, this is the from 2009 all the way to last year, 2022, IDC report. By the way, this is the latest report because IDC released the report in next month for the Q1, but this is the last year. So you see this is the revenue you can see from 2009 to 2012, 22. Last year we deliver, the whole x86 is 106 billion, so it's a huge market. And if you look at the chart here, from 2009 to 2015, the x86 market actually is going double. And in 2022, another double here. So compared to the 2009 to here, it's 4.3 times. So it's huge growth. And this rebar, you remember, is pandemic, the COVID-19 impact. But the x86 actually is not impact. And from this chart, you also can see the top one, the gray one. I believe that is an ARM chip. So look at the AUR, the server purchase cost. From 2009, it's around $4,000, and 2022 grow up around double. So that is 8,000. So this is the revenue view. How about a unit? Look at the volume. In last year, deliver almost 14 million. So this is the very good, big market actually. So you can see growing over and over. And in here, you also can see like another company, they're growing very fast. I don't want to highlight that. But look at the ODM, which is designed the server for the CSP server, the customers. They are contribute a lot to the AMD, but I believe that they will change it to the ARM server very quick. And I'm working the ISC, so I want to bring some information to you. Actually, ISC is the Infrastructure Solution Group, so we do the server to our customers. So our achievement actually is quite good. For example, in last year, if you look at the top 500 supercomputing around the world, there's 160 is our customer. So we are performing very good on the HPC side. Another one is the less than 25,000 US dollars storage. We are number one now. And according to the ITIC, our server reliability is very good. So that is a consecutive 9 years, we are rating number one. And our water cooling technology has more than 10 years experience on that. I will introduce that later on. And also, around the world, the top 10 CSP customer, we are 6 is our customer. So we performing very good on this area. And we do provide a system to our customer, like our storage and server called Syn System, and we have a solution called Syn Agile. But I don't want to spend time here, so just let you know that. And this is all of our portfolio, starting from OEM. We also can do HPC, and also we have the storage, software-defined, so on and so forth. So today is not a promotion time, so I just want to let you know we have all kinds of products can meet your requirement. And how we do the cloud is very important. So you see cloud, we categorize 4 kinds of cloud here. Like it's starting from the public cloud. Given you buy the resource from public cloud, actually we offer the server or storage to our customer to run the public cloud. And we also can build hybrid cloud for you. And not just that, we also can build a private cloud for you. And last one but not least is the edge cloud. So we categorize this cloud and we can provide solution to let you run all kinds of cloud you need. And because I'm from IC, so I want to introduce the worldwide development and the manufacturing side. Actually, Taipei is very important for ISG. We have more than 1,000 engineers working just next to the building. So if you're interested about Lenovo, you can contact with me. Welcome to our TDC all the time. And so in the ISG, we have 3 major labs. One is the Taipei, another one is the Beijing, and the last one, but not least, is in Raleigh. So we have 3 development centers around the world, and we have 3 manufacturing sites as well. So if you don't want to make it in China, we can make it in Hungary or make it in Mexico for you. Talking about the TDC, I just mentioned the next building. Actually, TDC is established from 2004, which is IBM time, and Lenovo acquired IBM System X in 2014. I was part of a transition. So there's one day, actually it's October 1st, I came from the same office, the same desk, the same computer. I didn't realize the pillar next to me changed from blue to red color. So after half a year, I read everything, nothing changed, but the pillar changed from blue to red color. So actually the center built from 2004, and we are keep running. So in the beginning, we doing the parts design, and later on, we changed that to the other solutions, like we can do 1-socket server, 2-socket server, and 4-socket server. Myself is responsible for 4-socket server. And that is I just mentioned 1-socket, 2-socket, 4-socket, that is a foundational. However, we also build the rack server, or high-density server, or the water cooling server, all built in TDC, Taipei Design Center. And we also help our customers to run in their data center. So we also build the IoT and also build the HPC and AI solution for our customer. You can see on the right-hand side, there's 2 customers, very unique and interesting case here. The bottom one is the Barcelona Supercomputing Center. If you look back to the 2017, Intel announced the Skylake. But what we do is they announced it in July. However, we published the Barcelona in the top 100. They were ranking number 13 around the world in 2017. And we published that in June. How come we can do that? The announcement day is July. We set up the system in June because we can do the early shipping with the customer, so we can collaborate with the different vendors provided. Actually, TDC, Taipei Design Center, we fly in more than 10 engineers to Barcelona to help our customers set up the system. So in here, I just try to say, our work in TDC not just design the server or design the system, but also we try to help our customer to make their success. This is very important. So we can engage with your case or your requirement, all kinds of requirement we can do. Okay? Talking about design, because the design is important. However, what unique from Lenovo, so you can see we have a lot of design different with the other company. For example, all of our system, we have a light-based diagnostic. When you open the box, when your system just have some component fail, when you open the box, you can see there are lighting there. This is from the hard disk drive, to the memory CPU, to the fan, to the adapter, to the power supply. So that makes the system very easy to repair. This is the one. The second one is all of our system we can support running at the 45 degrees C environment. So this is also important to our customer. This means our service is more reliable. And last but not least, is many of our design here, like you can use in a mobile phone to control your system, or not all of our server is toolless. So this is all the design for customer easy to use. And talking about the form factor, we have an edge server, can fulfill edge requirement, which is data generation. We can react at real time. And we have a very good server, the density, we can do the edge CPU in a 4U form factor. This is very important, very unique in the industry. And another one is lots of customers that are looking for front access, so we can do the front access as well. And we have a water cooler solution. As I mentioned, we have 10 years experience on that. Our water cooling system we call warm water. We are not using the cold water to cool out the system. We are using the warm water, which is around 45 to 50 degrees C. So this is an important design as well. And I'm talking about the design. So why you choose Lenovo. Another important one is the performance is better than competition in the market. Here is the proven point. In this month, all of our server, we own 463 world records. So that means our server can be performing better than any competition. And the performance better, not just for single application. If you look at here, from database to virtualization to power saving, all kinds of workload, we have lots of world records. That means our server can deliver better performance than any others. And I want to pause here, because if you look at the COMPUTEX this year, I think if you go to the exhibition hall, you can see everybody talking about the cooling. But I'm going to tell you, I agree with that, because the cooling is important. As I mentioned, we have 10 years water cooling experience, right? So I want to pause here. When you buy a car, this is a car. I'm going to buy a car next week. So when you buy a car, are you checking with the top speed? Are you checking with the how fast you can do from 0 to 100 kilometers? Are you, based on these two, to buy the car? Can you raise your hand if you buy a car, you check the top speed, you check the 0 to 100 kilometers? I'm sorry, 0 to 1 kilometer, maybe 3 seconds or how many seconds? Do you consider this cooling indicator to buy a car? Can you raise your hand? Only one? Oh, okay. So you buy a car very fast, right? But most of the people, they buying car not because of the top speed, not because of how fast they can do, right? So similar story to the server. So when you buy a server, actually you are not just looking at everybody talking about water cooler, what I should do. So I'm list down the requirement here. Actually, the driving for the water cooler, not just from the CPU or the other components, but also from the infrastructure. And also, they are driving from another one is the ESG. So everyone talking about this, but this is the different angle to talking about that. But when you prepare the water cooling, there's one very important indicator is, hey, do you have enough rack space? Do we have enough power to cool down the server? Because all the water cooling, when you implement that, of course, they can save in your power. However, for you to run that, you need more power. This is very important thing you need to know. So, and is your data center, are your data center ready for the water cooler? So this is all kinds of questions you need to check and you need to understand that. So in Lenovo, we try to do is from design to customer use, and after return, we provide 360 degrees to help our customer to make their journey to the sustainable or the ESG more successful. So I have some reference case here. So if you buy some server here, actually you don't need a water cooler. Just like I mentioned, if you buy a car, you need a very fast car or not. So this is the foundational question you need to answer, and you need to make that understand. So let me bring you some history here. So in Lenovo, we know the heat is very important. We know the power consumption is important. And we also know the packaging and transportation also another factor. So we try to put in that together, provide a total solution to our customer. So, and even including the end of services, your server, no matter which part of the server or the component you have, when you don't want to, when the server or the component you have is the end of life, how you can do that? You just throw to the waste cabinet, or we can do anything. Or maybe there have some value exist, you can do that. So in this point we mentioned here, the end of services, actually, we planned that from beginning. So this is important that it tells you Lenovo is very focused on the ESG. So let me give you some insight on that. Once again, you see the 2009, and I'm sorry because this is not ARM, but compared to the ARM, this is a small pie because I saw the ARM can achieve 192 cores, so which is not my CPU, not the CPU like this here. The reason I listed it because I was working for x86 from 2009. So you see the report all from 2009. So I actually experienced the revenue 4 times growth and the volume double growth. But look at here, from 2009, the CPU is only 6 cores, but 2023, this year, it's growing to the 60 cores. And the memory, the speed from 1333 megahertz to now is 4800, we call MTS or megahertz. So lots of improvement from CPU, from memory, and also the I/O. In the 2009, only PCIe Gen 2, but now it's PCIe Gen 5. So that is important. When you consider to adopt a new server, you need to understand what is your requirement, just like a car. Most of people buying the car not because of the top speed. Most of you buy a car because of comfortable or the services they provided. So I just mentioned the CPU and the memory. Dr. Sun also mentioned memory is important because in-memory computing, actually, in my view, is the next generation key points for the server. And look at I'm talking about the CPU and memory. Let's look about the I/O. So you have the system have better CPU performance, better memory performance. How about the I/O? So if you keep the table in the right-hand side, bottom right-hand side, you see, if you keep using the SATA drive, that means the SATA drive is only 6 gigabit per second. So you don't need a very fast computer. Trust me, the SATA drive is only 6 gigabit. Given you have an 8 drive, it's only 48 gigabit. PCIe Gen 3 is good enough. Another one is that if you have NVMe, then maybe that's important. And also the networking. So everyone knows the 5G is important. But actually 5G, the peak speed is 10 gigabit per second. So the server industry now, we are talking about, because we are support PCIe Gen 5 in here, right? And we are support by 16, which can support 400 gigabit per second, 400 gigabit per second. In the previous generation, which is 2020 or 2021, the server itself cannot do that. But now we can do that. So networking actually is another one to drive the transition and to gain the performance as well. So this is to give you the update here, but when you go back to you have the CPU, you have GPU, you have all kinds of things together. And when you look at your requirement, you will see, hey, I need a water cooler. Why? Because when you have a more hot CPU or GPU, your fan will be running more faster. So the fan power originally, if you have 400 watts, the server, and you increase to 1200 watts, the fan speed increased a lot, way beyond your imagination. So that's why when you buy a new system, that's why you need a water cooler, or you need to have more power to the whole system. And don't forget, from 2009 to 2022 or 2023, the server I did is 1U, 2U, or 4U. Is the space increase? No. So from very beginning, we defined the rack is 19 inches. 1U is this kind of like a pizza box. So at that time, 6 core, 2 CPU, for example, it's only 12 core. Now it's 120 cores. And memory increased a lot. I/O increased a lot. But the space is the same. So cooling actually is very important. We need to figure out. So in Lenovo, we provide all the full range of a solution. From the left-hand side, you can see we have real door heat exchanger, but this is actually not new. This is maybe from 10 or 20 years ago. And our water cooling, we have a full system, or we have the core system. We cool down the full system from CPU, memory, to I/O, to hard disk drive. This is all cooled by water. Or we can call core system, only cool down the CPU, the hardest one. And besides that, if the customer, you need a more cooling requirement, we also can provide you like a TTM, servo transfer module. So that one can bring the heat out. Also, we have we call liquid to air. So we have different kind of module. We will support our customer to run your data center. And this is an example. So I just mentioned we have different kinds of solution, right? So if you using the top one called the TTM, the thermal transfer module, and in the half view is the small box, and the CPU can only support up to 250 watts. If you need more in this small space, you need a water cooler. This is very generic requirement, right? But if you have 1U 2-socket server, for example, then the TTM can support up to 300 watts. Or bring we call liquid to air, still using the liquid inside the server, you can cool down to 350. And if you need more, the CPU or the other component more than 350 watts, you need the direct water cooling. Another one, the bottom one is if you have more space from 1U to 2U, so because the space increase double, so the heat sink can be bigger. So the heat sink can be cooled down up to 450 watts. So that means if you have more space, you don't need a water cooler. But as I mentioned, water cooler is important. So another one I want to tell you, when you adopt the water cooling, do you need more power or you can less power? Actually, this is the story. Because when you have more, because you adopt the water cooler, so the server you can run in a single rack is more, right? So from the left-hand side, you see, maybe from the co-location, if you rent this from CHT, Chunghwa Telecom, it's around maybe 12 kilowatts. That means the server can only install 16 servers. So if you rent this co-location from Chunghwa Telecom, you can only maximum install 16 servers. So when you, like now, you want to introduce the new server, then you can increase the space here because you have space you didn't use. But in the right-hand side, if you introduce the water cooler, because you can cool down more components, everything can water cool, right? So, but the single rack, you see the chart here, you can install up to 72 servers. So the power requirement from 12 kilowatts, here is 100 kilowatts. So that means you need more power in your data center. So many people, when they build the data center, they forgot this one. They only introduce the water cooling, the system that is changing some in your data center. They forgot to introduce the power. You know, the power is very limited in Taiwan right now, right? So for the data center, Lenovo try to help. We provide air cooler or the water cooler solution to our customer. And as I mentioned, our water cooler solution, we are using the warm water. So like this one, so we are introduce the server here, and the server can be cooled via the water. The water is inlet is about 45 degrees C, the outlet is 55 degrees C, so it's very easy to implement. All the component here is a standard component. This is very important. When you buy a water cooling, you don't want to buy a special component, right? Dedicated design for the water cooler. But this one, all the component is a standard component. That means you can acquire this via lower cost. Another one is if you want to introduce, you go to the COMPUTEX, everyone showing this. This is the immersion cooling. But don't forget that this one is good. However, the immersion cooling, you need how you build this in your office. Think about that. If you only require 2 or 3 racks, how you implement this to your office or your data center. So for the Lenovo, it's easier. We're using this one is easier because this one can be installed in the standard rack. By doing this, we also, as I mentioned, the ESC for Lenovo is end-to-end. So when we do the server design, let me show you this picture first. When you do the server design, we consider that. So when you need a water cooler, this one is an example. We sold this to Korea or sold this to the LRG in Germany because we can build the server in a rack. So we ship a rack to customer. So originally, you need if you buy a rack, if you recall, I have the chart here, a rack it can run in 72 servers, right? So if you install your server, 72 server, how many truck you need? How many bucks you need? So lots of waste generated here. You need a truck to carry all the waste out in your office. Maybe not just a single truck, maybe 3 or 5 trucks. Just carry out all the boxes you don't need that. But to us, it's easier. We build a water cooler like the bottom left-hand side. You just build a pipe there, water pipe there. And when we ship the server, it's a rackable server. So we only generate this kind of waste, right? Compared to this one, it's a huge saving. So back to the original chart I mentioned. So actually, we can save around 30%, and also we can provide high quality and faster to production. Is very easy because everything is tested in our manufacturing site, and we can simplify the operations. So think about that. And we're not just doing that, but also doing from our SimPad. So lots of saving. I don't want to read the number for you, but this one is important. So we build a system, not just provide you the computing, but also can save the earth. Last but not least, when you buy a server, you need as I mentioned, you need a water cooling. One is because the requirement, CPU is hot, GPU is hot. Another one is you try to do the ESG. You want to do this more sustainable, or you want to save the power. So this is all important. However, how to make this more greener? So we can help you do this. If you want to claim, you offset the CO2, or you want to claim you are green data center, Lenovo can help you to that. So we can, you see the first one is, if you need to offset the CO2, we can apply that to the UN, follow the UN emission forest projects, so we can do that for you. So we can apply a certificate. The server you buy and the server you used and the server end of life, we already pay the money to get the certification. Hey, this is green, you can do. So this is important to you to consider when you need a new generation of server, not just from the computing, but also the power. But another one is important is how you can deal with the CO2, this kind of issue. So bottom line is the sustainability is important. So hope what I just mentioned to you is consider your requirement. Don't just fall in up. Everything is water cool. Actually, that's not a true story. And when you prepare that, you want to introduce the new data center, then you need to consider not just the server, but also the whole data center. And also you get enough power, especially in Taiwan. Okay, so this is my presentation. I have 25 seconds. so actually I'm working the IT industry already 37 years. So I call my career is wide, because wide. So I started working from when? Do you know when? The company, the mini computer company has been bankrupt. And I also working in IBM 18.5 years and working Lenovo 2 times. So I just saw the lady, she was working for the manager today. So I got some awards, which is important in my life, like the MVP in 2008. But the most important thing is I like cycling right now. So if you like cycling with me, I'm 60 years old. I'm still cycling every year, 5,000 kilometers. So if you want to, given my body is big. So if you want to cycling with me, I've been cycling around Taiwan 3 times, so I can take you through all the journey. Okay, this is my presentation. Thank you, everyone, for your listening to my presentation. Thank you.
Thank you, Mr. Huang, for your inspiring speech. Please return back to your seat. So as we can see, with the rise of cloud computing, the demand for faster computing has increased as well, and so has the cost of developing the cutting-edge chips for companies and business. So how to build a more efficient platform with better performance has become more crucial. So at the same time, sustainability has become an important issue in the technology industry. So while pursuing the technology advancement, companies and business are also starting to think about how to provide a more sustainable future for the next generation, rather than just endlessly consuming resources. So thanks again for our 3 speakers sharing, and I'm sure that the audience are deeply inspired. So next, we will have the panel discussion. So first, I would like to welcome Dr. Sun from the National Yangming Jiaotong University onto the stage to lead the panel for us. Next, I would like to invite all the speakers back to the stage. Let's welcome Mr. Awad, Mr. Wig, and Mr. Huang back to the stage for the next panel discussion. And now I will turn the floor over to Dr. Sun for the follow panel discussion. And the stage is yours, Dr. Sun.
Okay, thank you for staying for the panel discussion. I think we heard all the great inspiration from our distinguished speakers. I also learned a lot personally. And so right now, before everybody's too hungry for lunch, I have some prepared questions, and we also welcome audience. Please feel free to ask questions to the panel. I'm sure they would like to share their wisdom and experience with everyone. So I think we heard a lot of great things in terms of cloud native computing, which really reduce the power a lot, which is a challenge. You said the data center power is going up right from 4% to 11%, I mean, by 2030 or something. So maybe we will start with the first question to all the panelists here. Power definitely is one important challenge going forward. So name your top challenges for these for the next leap of computing. Yeah, go ahead. Yes.
Okay, so the challenge from us is because we are system designer. So CPU now is very hot, GPU is very hot, I/O is very hot. So we need to combine it together, provide a solution. But our customer is not ready. The power not ready. The data center with the water cooler is not ready. So we need in the industry pick up everything and then make the changes from the original system to the new system, which provide very powerful in terms of CPU, memory, or other stuff. So system integration is important. However, customer adoption is another one. I think that is an important one.
Yeah, really, and to share the really a very effective warm water cooling technology that just shows that there are many, innovations that we always count on to overcome some of the challenges.
Yeah, I would say hopefully we can help make your job a little bit easier over the next couple of years. Obviously at Ampere, we're taking a bit of a different approach versus trying to go and re-architect the entire system and mitigate the effect of kind of runaway power consumption. We're really looking to reduce the amount of power that's consumed by the CPU itself, but still deliver more and more performance. So hopefully, as we look over the next decade or so, we won't need to go in and procure more power for more data centers. We won't need to move to, say, fully immersed cooling approaches. We'll be able to actually just fundamentally reduce the amount of power that's consumed from the CPU and from the server, but still continue to increase the overall compute capacity. So I mean, there's multiple solutions to this, but I think looking at the fundamental problem and really changing our trajectory, I think is really important from an Ampere perspective.
Thank you, Mohammed.
Yeah, I think the fundamental issue is that you've got more and more data coming into the system, and it's requiring more and more compute, and there is nothing on the horizon that implies that that's going to change in any meaningful way. And so I actually sort of agree with both of my colleagues here in that it actually is going to require multiple things. I don't think you can solve it with strictly a different CPU. I don't think you can solve it strictly with water cooling. I don't think you can solve it with existing software infrastructure. I think you have to really sort of reimagine what the infrastructure is and look for efficiencies everywhere, because the fact is that the data is rising at an exponential rate, and it's really going to take everybody kind of innovating on all different trajectories to to make it happen?
Yeah. So nobody mentioned, actually, semiconductor technology has been also evolving and continue to innovate and trying to tackle some of these sort of performance power is always, performance power, density, and the cost, and then time to market, at least from the technology guys. So now, I did mention the heterogeneous integration, 3x3D, and you all show some examples. So I know, as Mohammed, you mentioned that it takes multiple sort of innovations to really help us, going forward to provide more compute while still staying within our sustainable kind of requirements, sustainability requirements. So, but even though there are multiple ones, what are the key enabler in your mind, going forward that you would like to have? I alluded to some of these in-memory computing, and I didn't talk about quantum. I didn't talk enough about the cooling technology, but yeah.
I think one of them, the approach that we've taken at Ampere, is really still in its infancy. So I think that shift from a scale up to a scale out computing model within the CPU, I think that there's been a lot of work done on the software side within cloud infrastructures to take advantage of that type of an approach. But I think that there's still a lot of promise over the next 5 or 10 years to continue to utilize that type of scale out approach to create efficiencies and reduce a lot of the inefficiencies of the scale up approach. And it's going to require some new technologies from a semiconductor perspective as well, both on the fab process side, so ensuring that from node to node, we see continued improvements in power per transistor and not just performance per transistor. So reducing the transistor leakage power over time as we move to new process nodes is going to be important. I think also on the packaging side as well as the integration side. So improved and innovative packaging techniques that allow us to continue to scale out beyond the reticle limit from a silicon perspective, and then also advanced interconnect technologies to continue to reduce the amount of power we're consuming from chiplet to chiplet.
Yeah. I mean, I would agree with all that. I mean, I also think sort of reimagining, where data is processed. If you think about the journey of data from that endpoint all the way up to the infrastructure, at every hop along the way, you've got to kind of make a decision. Do you want to, analyze the data? Do you want to pass it along? Do you want to store it? Do you want to filter it and drop it on the ground? I think, reimagining that and sort of the fluidity of workloads and where they sit within that entire continuum is going to be important because there's efficiencies to be had there.
To me, the most important thing is how to make everything together and support our customer. I have one customer, they have a different suppliers, 10 suppliers, and they call, the issue happen. So 10 suppliers that in the meeting, everyone try to prove, hey, the problem not from me. So this is the customer say, hey, the problem still exists. Everyone has no problem. The problem is customer. So for Lenovo, we try to do everything synchronized together and then provide support to our customer to make them success. This is important, very hard to do.
Thank you. So today here we don't have Intel, we don't have the AMD, the x86 folks, except Andrew, you have been using those.
He's going to be ARM now, though.
It's going to be ARM. So we only have kind of a one-sided or lopsided. But still, coming back, looking at the data center, right? Traditional, it is specialized. Like IBM has proprietary, right now it's what, Z series or whatever. But x86 has been really the workhorse for the data centers. But with Ampere, with ARM and things. So what do you see in terms of the composition or if when people start to build out more data centers, right? What would, from a chip and also from the hardware perspective, who will win at the end? The Intel, the x86, or what kind of mixture?
I think, you know, I think the reality is that it's not about the architecture, right? And that's going to seem odd coming from the ARM guy, right? It's not about the architecture. It's about the solution. And it's about solving the compute problems. And so at the end of the day, what is going to win is going to be innovation and the right compute for the job. You know, we think that, you know, our ecosystem is well positioned for that. We think that they're well positioned for that because we give them the freedom to go off and innovate. You don't have to just take the SoC that's on the shelf. You can go and build and design and experiment. And in some cases, you're going to be right. And in some cases, you're not. But you have the freedom to go do that. And so ultimately, that's why we think we have a winning formula.
I totally agree with Mohammed on that one. I mean, I think if you look at my talk, it might seem strange. We've built a CPU that's based on the ARM ISA. I'm not sure I said ARM once during it, but that's because when you look at the macro problem that we're trying to solve, the macro problem is very different. The macro problem is how we deliver more and more compute and how we reinvent the way that compute looks at the CPU level. And so the ARM ISA is a great enabler for that. That's what allows us to go and build what we're building. It allows us to break free of all the constraints that x86 has, all the baggage that legacy architecture has. But at the end of the day, it's not about the ISA or the architecture per se. It's about what you build with it. It's about building something that is innovative, that's purpose-built for a specific type of a use case, something that's innovative that breaks free of all of the legacy constraints. And I just think that looking forward, it's increasingly likely that approaches like what we're doing at AMP here with our cloud-native processors, that will end up being the predominance of data center deployments, not something that was built a couple of decades ago for a very different use case.
I think it, from my point of view, the first one is the important. Our customer or every customer, they can win because they have multiple choices and run the different workloads. So for customer, they can have multiple choice and even cheaper. This is one. The second one, because everyone pay attention on the sustainability, so the Earth eventually will win because we can make the Earth more greener, and so the Earth can be sustainable more long time. So I think these two key factors can win eventually.
Okay, so it's not about the architecture, but if you look at the general purpose, no matter what architecture you use, and specialized AI accelerators like NVIDIA's GPU with a lot of CUDA and other, total solutions from them. In the future data center, between the AI, computing and the traditional computing, what do you see as the trend going forward?
Thank you. I think the trend, still they have different requirements we need to meet, and a single product cannot meet all kinds of requirements. So we have a special design team, like we have ODM Plus, so we can design the server for specific requirement, double the memory or double the GPU, something like this. So we also can design ARM to our customer. So we still facing this kind of challenge, and eventually I hope the general purpose can fit all kinds of requirements. I hope that day can be happen.
Okay.
I would just comment that, I think we get ourselves in trouble when we try to narrowly pigeonhole things to a specific solution that's going to solve all problems. Parallel compute architectures, things like GPUs are obviously fantastic for certain uses where you're driving lots of parallel computing, right? When it's all happening at the same time. But it requires that type of implementation, and that's good for some use cases and not great for others. CPUs are good for other sets of use cases where, you need a more serialized approach. So, you know, and I think the ORAN example that we talked about earlier, that I talked about in my presentation, is a fantastic example. That ORAN stack is an example where, you know, there is a meaningful, a significant portion of the stack which needs a CPU to operate so that it can actually manage the accelerated side, which is providing fantastic benefits in terms of the L1 and L2. And the power of that solution is bringing both of those technologies together, not either one or the other.
I agree. I think when you look at it, it's, you know, you look at the problems you're trying to solve, look at the data types, look at the instruction types, and there's certain categories there that are very specialized. You know, AI training is one of those examples where something like a GPU does an exceptional job because of the uniqueness of the data structures and the way that the data is being processed. It's very, very good at that type of a workload. It's not very good at completely different types of workloads. So I think, you know, there'll be these pockets where domain-specific accelerators are going to be very, very powerful. There's also a really, really large need for, you know, versatile general-purpose compute that runs all of your C applications, that runs Java, that runs Python, that runs all of the stuff that's running everywhere in the cloud today. So I think it's going to be a complementary approach. And you know, Mohammed's right. It's about focusing on the use case. There's going to be a wide variety of solutions for different things. It's not going to be a one-size-fits-all solution. And you know, the problem that we've set out to solve is how do we create something that's incredibly versatile for that general-purpose problem statement, not a super narrow, specialized problem statement.
So I guess everybody's happy because that means job security, no matter what you are working on. But if you look at the stock market today, right, NVIDIA's going again a single day, 20% up or whatever. And NVIDIA's revenue on the data center kind of a business actually surpassed Intel's. So that says something because of the computing, right, for different applications. So if you have your crystal ball, you know, right now it's 2023, but in 2030, what would you predict in terms of we need all kinds of architecture, all kinds of processors work together complementarily to make. But if you look at the business volume and because ChatGPT and NVIDIA solution altogether combined democratize AI, right? It's the iPhone age of AI has arrived. So mom, dad, and I mean grandma, you know, whoever can just use generative AI, this type of utility, or just like using the iPhone anyway. So what would be your, you know, crystal ball in terms of let's say if you have a $1 trillion business, how much will be this AI computing versus the other sort of kind of a computing? Take a guess.
Okay, every time starting from me, I'm sorry. So to me, 2030, I just mentioned, I hope I can be retired. But to me, actually, it's this one thing, because all kinds of working change our life. So I hope the life can be even better. The change is helping to the healthcare, to help the human being can be live better. This is very important, and the earth can be more longer, and everyone can enjoy the earth, and maybe all kinds of different applications make our new generation, they can be smarter, not spend their time only on the screen. This is not good for us. So everything can be changes, but my focus will be our life, and Lenovo can make everything, try to help the human being to make improvement for the next 7 years you just mentioned.
Thank you.
Yeah, in terms of the specific, you know, I don't know that I can predict what the technology will be over the next 10 years. You know, I couldn't have predicted that if I go back 5 years, that large language models would end up becoming as important as they are, and that we would see these 50 billion plus parameter models popping up. But I think regardless of what the technology is, whether it's additional model types within AI, if it's new types of computing that increase the relevance, like quantum computing, I think the key problems that we're trying to solve remain the same, and the challenges will remain the same. How do we harness all of this data to improve our lives and to do so in a sustainable way? So I think the solutions and the approaches will adapt over time to meet those objectives. But I can guarantee I can guarantee whatever we come up with in 10 years, it's probably not something that any of us here today we're thinking of.
Well said. I think the only thing that I would add is that one thing that we can all agree on is there will be a lot of compute. And I think it's our job to find ways to kind of enable that and make that happen.
Yeah.
So I think if you're talking about the future, I can look back the computing. What the important one is the in-memory computing. So if you move the processing like SAP HANA, moving database from the traditional hard disk drive, a part of a memory cache, the kind of algorithm move to all the memory, then the speed will be booming. So that one can be changing our life. Not our life, but changing the corporate life. Very, very simple, but not very hard to make that. So in-memory computing, actually, I hope can be changed, because right now the server can be 20 terabytes, 32 terabytes. It's very big. However, no one uses that.
Yeah. Actually, we can, if anyone from the audience would like to ask any questions, please interrupt. Feel free to ask. Yeah. Yes, please. Do we have a microphone for?
Thank you, Ryan. Hello. So thanks for the very interesting presentation and such an amazing opportunity to be here and ask the question in person. So we seem to be like in a very ARM-centric panel discussion over here. And I know like the market share looks great, so thanks Mr. Watt for showing this journey that we have with ARM recently. So, but it hasn't been long since Intel was on top with x86 everywhere. And now ARM is even taking that huge piece of a pie of the HPC segment with cloud computing. But I'm surprised like we don't mention anything here about specifically talking about break-in constraints. So I'd like to bring another party, speaking about open source. So how do you feel about RISC-V? So I hate to possibly put in my former Intel colleague over here in the hot spot. But do you, Jeff, consider RISC-V as a possible diversification for a portfolio of the product that you're looking forward? And Mr. Watt, do you feel any pressure from RISC-V solutions from instruction set coming into the space and possibly taking some part of your market share? Thank you.
All right, I'll give Mohammed some time to think about about his answer. I'll just say, whether it's fab technology, whether it's other enabling technologies, we're always looking for something that can help us to achieve our objectives. And the ARM ISA and working with ARM on our processors has proven out to be the right approach for what we're doing, and has enabled us to build something incredibly innovative that's allowed us to surpass what Intel has done over the last couple of years. I think that having an incredibly robust software ecosystem surrounding whatever your technology choices are is incredibly important. And when you look at the maturation over the last 10 years of the software environment, the open source community around ARM, that's been a huge enabler. Grab any Linux distro off the shelf today, and it runs on an ARM-based processor. Grab any hypervisor, it runs. Grab any open source piece of software, it almost undoubtedly runs. And so I think that's been a huge enabler. So whatever technologies are out there need to meet those objectives, as well as being able to deliver amazingly high performance for it to be a viable solution in the market.
So Yeah, so we get asked the RISC-V question all the time, and it's a good question. The reality is that it's our job to stay competitive, and that's what we do. At the end of the day, and I said this before you asked the RISC-V question, it's not about the architecture. When people choose what compute they want to deploy, those consumers of compute, they're looking to solve a problem. It's not about which architecture I'm using. It's which solution gives me the level of differentiation and enablement that I need at a price target that makes sense for me to go deploy at. And so when you think about, deploying compute, the question you have to ask yourself is what's important to you. If a software ecosystem is important to you, if support for tooling and for a broad semiconductor ecosystem, an ODM ecosystem, a foundry ecosystem, if those are things that are going to help you achieve your goals, then you're going to choose the solution based on that. Now, if that's not important to you and there are areas that you want to differentiate and maybe break things like compatibility, you may choose another offering. But that's ultimately up to the consumers of compute, and it's our job to continue to be competitive on those vectors.
Before we summarize, we did mention about quantum computing, and that seems to be the sort of, if it becomes commercially viable, it will be a major quantum leap for some of the computing workload. So I'd like to hear your comments about the future of quantum computing and its impact on the cloud computing.
Yeah, I can take that one first. Quantum computing is an area that's really interesting for us. As I mentioned before, there are specialized workloads that benefit from very specialized types of computing, and quantum computing could be one of those types of computing. We actually have a partnership with a quantum computing company called Rigetti, and we've been working with them to create these hybrid classical quantum computing systems that are hopefully going to allow them to achieve near quantum advantage soon. They have a very interesting approach because their approach is very scalable, trying to scale out to hundreds of qubits. It's also very accessible via the cloud. They've made the software work well, abstracted it from the user who may not be aware of how to create a quantum circuit, and they've made it very accessible via the cloud so that it can scale out. So I think if quantum computing can demonstrate either near quantum advantage or eventually quantum supremacy in specific domain areas, and if it can also become very accessible and scalable via the cloud, it could be a really interesting, powerful technology over the next decade.
Yeah, so agree with you. So Lenovo is a system provider. So we need once the content is ready, no matter the component level or the semi-final product available, we can make the system available to support it. This is one. The second one is the ecosystem needs ready. Because not just the hardware, we need a software or application to support the system we do. So I hope this one can happen before my retirement.
Good.
I mean, I don't have much to add. I mean, I think Jeff and Andrew did a good job kind of summarizing. I mean, I think quantum's super interesting technology. We're obviously, like a lot of folks in the ecosystem, looking at it. It's an area where, as compute matures, it's something we absolutely want to.
Okay, I think we are coming to an end. Before we close, maybe you can say just one sentence or something. We didn't rehearse, by the way. So to the audience, what either your dream or what you wish the most or whatever, your final comment, just one sentence.
Everyone can be AI. So hope AI change our life.
Good. Yeah, please.
I hope next year when we're back here, I hope everyone here is using Ampere processors. I just challenge everyone, kind of break the status quo. Don't be afraid to go out and innovate and try something new. It's how we're going to move forward and solve some of the key challenges in our industry.
Mohammed?
And I would just comment that there's tremendous amount of data. A lot is changing all around us. And I think it's really going to require innovation on all different vectors, whether that's cooling or sustainability or pushing the boundaries of what's possible in a particular SoC. I think it's really about the innovation that each and every one of us together bring to the table. That's how we make it to 2030 and beyond.
Yeah, I will close it by still saying that the best is yet to come, because all the panelists are really optimistic about, there's just insatiable demand of data, and human just wanted to do use whatever tools. So data center, whatever computing that we can use. So it's good opportunity for everyone, in this industry or in the academia or whatever, to continue to innovate. So let's end with let's go, continue to innovate. Okay, so let's give a big applause to our distinguished panelists. Thank you very much.
Thank you, Dr. Sun and Mr. Awa, Mr. Wig, and Mr. Huang for this inspiring panel discussion. And you can now get back to your seats, return back to your seats. And thank you all for participating at the morning sessions of Chips and Semiconductor Summits of COMPUTEX Forum. And I hope you all have gained much insight and inspiration. Our afternoon sessions of the Chips and Semiconductors will start at 2:30 this afternoon. Speakers from Texas Instruments and XP Supermicro, Solidigm, and ST Microelectronics will join us this afternoon. See you guys later. Thank you.